Hello, Connor here for AppVisions with another photo fact of the week. This week we're going to be talking about focal length. What does focal length actually mean? As I'm sure you all know, larger numbers are more zoomed in and smaller numbers are wider. But what do the numbers mean themselves? That's what we're going to talk about today. Like when I say I have a 300 millimeter lens, what does the 300 millimeters actually stand for? And how would that compare to, say, a 20 millimeter lens? What is the difference? So, to answer this question, we're going to turn to physics and some optics equations, because that's where these numbers actually come from. This all hinges upon the lens maker's equations, ultimately, but it's all based on a thin lens approximation. So that is, if we say that this is our lens right here, that's something that will focus light onto points when it comes through. If this is the normal angle, this is one of the important things to keep in mind. We are saying that this lens is so thin, the thickness of the lens from here to here is really small compared to all the other distances we're working with. So say we have an object out here. This distance, we're going to call it O for object distance, is so much greater than the thickness of this lens that we can just kind of count this as being negligible. So here is what we are going to work with. Let's say that we have an object out over here where this white dot is, or a series of objects, right? Like this is a big object over here. This is our object. And it's giving off light rays, and we're going to focus on the parallel, or the light rays that are parallel to this normal plane, right? This is normal, so all the light rays are parallel to that. And by definition of a lens, when parallel light rays strike it, they all get bent based on how far away from the center of the lens they are, how far away the point is from the normal incidence line. And so, where these all meet, right here, because they do all meet at a certain point on the normal line, is the focal point. And this is where focal length comes from. It's actually parallel. You see, if a beam of light was to come from this side, it would actually go over here. And then if we were to say this has a distance of f for focal length, this would have that same distance f. So that's what focal length actually is. And you can find the focal length through a nifty formula that is 1 over the object length plus 1 over the image length equals 1 over the focal length. And I'm going to draw out what that really means. So we have our lens here again, right? And we have our normal, and we're going to have our object out here, right? I'm going to draw it as kind of a smiley face. So we're going to kind of do we're going to use a little bit of intuition here, but follow with me. So we know that lines that go parallel will get bent to the focal point, right? So we'll call this is the focal point. So this is F right here. This is our O right here. And we can say that every little point on this image is going to radiate light off in all directions. We're going to treat it as a sum of point objects. So that means that this light right here, this little point, this eye, is going to radiate light off in that direction. It's going to radiate, the other line that we care about is right here, right? When it goes right through the normal, it's not deflected at all by the lens. So it's just going to continue straight. And then what we also care about is going through the focal length on this side, right? Because then we know that it's going to be bent out parallel, because we know that the lenses are symmetrical, like we said earlier. So we see that all of them meet over here. So we can trace this point to right there. And then we can, let's say we'll look at the mouth now. slightly different color. So we say, oh, the point down here, there'll be a line going out parallel. It's going to go to that. Okay, a line going through the center. It's going to go to that. And then a line going through this focal point. It's going to go to that. You see it meets up down here. So that's another little point right here. And if we do this same tracing of these three principal lines for every point on this image, you will see kind of that, oh, we traced out a smile up here. Oh, and this is down here. And we've created our image, right? So it's a upside down image, but it is this recreation of this. And it's going to be all in one plane. I'm saying this is kind of all on one surface right here, right? Like it's a surface perpendicular to the lens. And so it's been recreated inverted over here in another plane perpendicular to the lens, and that is the image distance. And so in terms of a camera, this is your lens, this is the plane of focus, and this is your image sensor. So obviously, in the case of a camera where we have a lens that's fixed and mounted, we can't change this I, and we can't really change this O. So there is more than one piece of glass in here. Those are the focusing elements that move around. So this is obviously an oversimplification, but you can kind of see if you were to move this F in, right, this focal distance in for a small focal length, you would have all of these things being blown up really, really wide, right? Like you can see it's a wide-angle lens. Or if this F is really far away, it's going to be a telephoto. And so this is how you can see how focal length actually comes to label lenses. And then you think, okay, if I have a 300mm lens, this F is going to be 30 centimeters long, so that's a really long lens. So you start to see, oh, super telephoto lenses are going to be really long. That involves a lot of materials and metal and glue to hold everything together, and that's why super telephoto lenses are so expensive, in addition to needing a lot of glass to have wide apertures, that is. So, hopefully you find this as interesting as I do. And also note that this is only just the beginning. This is the tip of the iceberg, right? Lens designs nowadays will have more than 10 elements if they're really going to be a good design. And this is just a single piece of glass. So this is obviously a extreme oversimplification because you can just kind of combine all these things together. But this is basically where focal lengths come from, and I thought you guys might be interested to know. So if there's anything else you want to know about for next week, leave it in the comments below. Until next time, this is Connor signing out for AbVisions. See ya!